If I double it, I get the arc. This arc, AC, goes with the angle that's inscribed. This is called an inscribed angle. Angles are always half of your arc length, or if you like, you can think of it like this. Double the angle is equal to the arc measurement. This is the measure of my arc AC. And I'm going to color code it. Now I'm going to look at the opposite angle. No, if you're going to use a minor arc, then you want this one to be your acute, right? And this one is going to be my major arc, so I'm going to use the obtuse angle for this one. This arc, or this angle, is associated with this arc. Now this happens to be a major arc, so I have to use 3 letters to describe it. Remember, your minor arc is less than 180. If I double angle B, I get this arc out here. This, again, is a major arc, so it has to have 3 letters. CDA or ADC. Doesn't matter which direction you go. Now, what you should notice is that if I add the arcs together, I get a whole circle. If I add the yellow arc with my pink arc, CDA, I get 360 degrees. I get the whole circle. This arc plus this arc gives me 360 altogether. First step, the angle doubled gives you the arc. This angle doubled gives you the rest arc, the rest of 360. When I add the arcs together, I get 360. And I'm going to do substitution now. I'm going to put this instead of the arc. Instead of this arc length, I can put 2 angle Ds. This arc right here, this yellow arc, is 2 of these. So I'm going to put, instead of the yellow arc, I'm going to put 2 angle Ds. What am I going to put instead of the big arc? Instead of this pink arc right here, I can put 2 of these angles. All I'm doing is substituting. I'm putting this instead of that. And when I add that together, I should get 360 degrees. All we did is substitution. Your last step is to just do some algebra. All you have to do is divide everything by 2. I'm going to put this in red. This is the division property of equality, but you could just put that you did algebra. I'm going to divide everything by 2. That gives you the measure of angle D by itself plus the measure of angle B by itself, because those cancel out and give you 1s. $360 divided by 2? 180. And what that says is that the opposite angles are supplementary by definition. When you add angles together and get 180, that means they're supplements. That's the definition of supplementary. So angle D and angle B, the opposite angles, are supplementary. By definition. Sorry, I messed that up a little. This is your whole proof. Any diameter at all, it's going to go through the center. You can put it here or here. It can go anywhere. Any diameter. And I'll call it DI for diameter. I think I'll call this A. Now, what I'd like you to do, put a point anywhere on your circle. Doesn't matter where. Put a single point B anywhere on your circle. Does not matter where you put it. You can put it here or here or here. Anywhere on your circle, put a point B. And what we're going to get is an inscribed triangle on the diameter. This triangle is going to be defined like this. If you put the B down here, you'll draw it at the bottom. I'm going to draw this one to B. So I'm going to go I to B and B to D. And I want you to see what kind of triangle this is. Measure your angle and see what you get. Mm-hmm. Oh, what? Yeah, find the angles, yep. Did y'all measure this angle up here? What's your angle B? Measure it and see what you get. Did you guys get 90 degrees for angle B? That makes it a right triangle, and there's a way to prove it. And the way we can prove this is just like we did with the last proof. I'm going to look at this inscribed angle, and it's going to go with this arc, isn't it? Right here. See this arc? This angle right there goes with this arc. How big is this arc, Phil? Right here. This is 180. The central angle is 180. It's a straight angle. This is 180 degrees. Remember that the arc is always double the angle. 2 times the measure of the angle, just like we did before, is equal to the arc, DI. Yeah, I would. I'm gonna, it just makes it a little bit easier to read for me anyway. This angle B, if I double it, I get the arc. How big was the arc? This arc is 180. It's half of a circle. This is just substitution right here. And then I just do algebra. What do I do to solve this for angle B? Divide by 2 on both sides. We're using division, property of equality, and we get the measure of angle B has to be 90 degrees. That makes this a right triangle by definition. These little 3 dots stands for therefore. When you're making proofs and you want to prove something, this is your last statement. This says therefore right there. That's what those little dots mean. Triangle, DBI or IDB, it doesn't matter what you call it. And again, it's by definition, because that's what we mean when we talk about a right triangle. You just get a 90-degree angle gives you a right triangle.